Okay, so now we're getting ready to go into the next part of this section. I hope you took some time to go back and get more familiar with what we've already gone over and played around with the code a little bit more. That's why I break these videos down. So let's get into it. All right, so now we're in 2.2.5. Let's go into the curriculum. Okay, we got everything running. So let's add comments to your code. As programs get bigger and more complicated, they get more difficult to read. Good programmers try to make their code understandable to others, but it is still tricky to look at a large program and figure out what it is doing and why. Also, there are times when programmers need to isolate or ignore certain portions of their code as they are testing it. In this try it box above, you were instructed to remove a line of code in order to create a compiler error. However, programmers are usually reluctant to delete lines that they might need to bring back. Best practice encourages us to add comments to our programs. These are notes that clearly explain what the code is doing. A comment is text within a program intended only for a human reader. It is completely ignored by the compiler or interpreter. In Java, the 2 token indicates the start of a comment, and the rest of the line gets ignored. For comments that stretch multiple lines, the text falls between the symbols / ****. So it has an opening / with the star and a closing ***. Comments can also be used to temporarily skip a portion of the code when the program runs. Instead of removing double Celsius in temperature converter, we could comment out the line. This would increase the same compiler error and one error we wanted to witness, but it would preserve the original code and allow us to easily reactivate it by removing the 2 / tokens from the line. And that's what we did. So we have it right here. I have the 2 / and I did a shortcut where I did Control / on the PC. And I have to remove this right now because I got these 2 declarations at the same time within the same file and only need to do it once. So you can see that that gives an error. So let me go ahead and tap that back in position. So we've already played around with the comments with the /, but if I just do 2 /, that's just for one line. But if I want to comment out multiple lines, remember I have to do this right here. I have to add that open and closing. Oh, let me get rid of that one because it did it for me. That's how we close it. Let me see what is going on here. Look like I got a little error right there. Oh, that's because it's giving me errors because of everything else because I commented out that code. But that's how you comment out more lines. So let me push this back. Okay. So play around with that to make sure you understand how that works. Okay. Here's an example. Now we're getting down to 2.2.6. Collect input with the scanner class. In Java, scanner objects make getting input from the user. A file or even over the network relatively easy. For our temperature conversion program, we declared the variable input to be a type scanner. So we made this a type. We want our program to prompt the user to enter in a number in the command line. We accomplish this by creating a scanner instance using the word new and then calling the constructor and passing in it system.in object. Here we go right here on line 11. Notice that the scanner object is assigned to the name input, which we declared to be a scanner object earlier, right here. And remember, we're importing that in right here on line 3. That's how we have access to that class. And you know those system statements we've been using, like system.in above here and system.out print line. This is like a console.log right here, the system out. These are console.logs in JavaScript. But in Java, we use system.out.println to print statements. Remember the keyword print. Whenever you see print, whenever you see display, you know you want to print something out. This is the syntax you use. Well, systems itself is a Java class. System.in is similar to system.out, except as the name implies, it is used for input. So I'm using system.in because I want to input something and I'm getting access to that class. So here on line 11, I got the instance class of scanner, but I'm also passing in that system.in, which is a class itself or an object, so that I can use the input variable, and it's all being stored in that input variable that I declared as a scanner. Still with me? Note, if you are wondering why we must create a scanner object to read data from the system.in, when we can write data directly to system.out and using println, you're not alone. We will talk about the reasons why this is so when we dive into Java streams. Next, line 12 asks the user to enter a number. And in line 13, we use input to read that value from the command line. So here we go. We're going to enter a number. We're using input and we're using next double. We're going to explain what that is now. Here again, we see the implication of Java being a strongly typed language. Notice that we must call the method next double because the variable Fahrenheit was declared as a double. Because Java is statically typed language, we must call the appropriate method on the scanner object to ensure the entered data is of the correct type. In this case, the compiler compares the types of Fahrenheit and input double. Because you notice here on this input double, I am adding what? It says here, next double to the input. So the input right here is the print lines, print out. So system in is the input, the information that's going into the input. And then I'm going to ask that question. Once I ask that question, now I have an input next double. So whatever I enter in, it must be a double. That's what next double means. It can't be an int, and because that's what it's expecting, and it can be a float. It has to be a double. Okay, where am I at? Because Java is statically typed language, we must call the appropriate method on the scanner object to ensure we enter the data is of the correct type. In this case, the compiler compares the types for Fahrenheit and input next double, because Fahrenheit is a double, and throws an error if the two do not match. The table below shows some commonly used methods of scanner class. There are many others supported by this class, and the Oracle website provides the complete list of the scanner. So as I click there, I want you to come here and I want you to read this. This is important. Here in the scanner methods, we got method name has next is a Boolean, returns true if more data is presented. Has next int Boolean returns true if the next item to read is an int data type. Has next float Boolean returns true if the next item to read is a float data type, and so forth and so on. Just go through here and read all of these to get familiar with what is there and what's available to you. So in 2.2.6.1, the closing scanner. To collect data from the command line or other sources, create a scanner object. This opens up resources in your machine to manage the input. And these resources remain open. Notice here, these resources remain open even after the required data is loaded into your program. Leaving a scanner open is like keeping a window open in your house 24/7. Anyone can climb into your home and you lose money by trying to heat and cool your space while it is open to the outside air. Similarly, an open scanner can allow unintended access to your program, and it ties up resources that might be needed elsewhere. Best practice states that if you open a scanner object, close it after it finishes its job. Line 14 does this in temperature converter. We do the input.close. So if you have the input over here, make sure you close it. So input.next double, you want it to close once the information is entered in right after line 13. Moving 2.2.6.2, moving beyond the command line. The scanner class serves as a kind of adapter that gathers primitive data types as inputs and convert them into object types. It converts an int into an integer. We will discuss the purpose of this later, but for now, know that the adoption makes low-level data types easier to use. For the temperature conversion program, we collect the user's input from the command line, but there are other options for collecting data from our program. In future examples, we will create a scanner object by passing a file object as a parameter instead of system.in. Okay, check your understanding. Now we made it to the end of this section. I want you to go back and continue to go over this information. Remember to use your resources. Those documents that we told you to go back and look at. Read those. It has more information that's going to help you better understand what's going on. One of the biggest issues as a developer, a new developer, is not wanting to read the documentation. And then you run into issues and you're struggling to understand them because you're trying to figure it out without going through the resources. These resources may help you streamline and avoid a lot of unnecessary headaches in the future. Because if you run across an error, you can say, oh, wait a minute. I remember reading that in the Oracle documents. Oh, let me go check there. Now it shows me how to fix it. Instead of you being frustrated trying to Google it and you don't find the answer. And now you wasted a lot of time trying to find the answer. And finally, when you do find it, you may come back to your Oracle documentation later and say, oh, wait a minute. That information was already presented to me. Had I read that documentation earlier, I would have known that. So remember, the more you practice, the more you improve. See you in the next section.